is PreCalc 11, Chapter 8.5. This time we're going to be graphing reciprocals of quadratic functions. And we can take advantage of the zeros, invariant points, and the vertex to give us the key points to sketch the reciprocal function. We want to remember that g of x equals 1 over f of x, and that 1 equals 1 over 1, and negative 1 equals 1 over negative 1. This is our invariant points because the value of g of x and f of x are the same. And g of a is our vertical asymptote when we have f of a equals to 0. Now there's two ways to graph the reciprocal function. We can graph the quadratic function and then use the key points, or use a table of values of the quadratic and reciprocal functions. And we use the latter when there aren't many key points to use. Our first example is graph the reciprocal of y equals x plus 1 all squared plus 3. This is in standard form. Our vertex is negative 1, 3. So it's easy to plot this. A is equal to 1, so we do the standard 1, 3, 5, etc. So our vertex is our only key point. It's a minimum point, so it is our maximum point for the reciprocal. Our vertex is also our axis of symmetry. So we have x equals negative 1. And our vertex here is negative 1, 3. Because our value is 3 here, our reciprocal is 1/3. We don't have much to go on, but we know this is going to positive infinity, so it'll go 1 over positive infinity, which means we are approaching our horizontal asymptote from the positive side or above. Okay, so the axis of symmetry for the quadratic is also the axis of symmetry for the reciprocal. And just to note, the horizontal asymptote is always going to be y equals 0 for a quadratic. If a is greater than 0, we're going to be approaching the horizontal asymptote from above. If a is less than 0, then we're going to be approaching the horizontal asymptote from below. Let's look at another example. We're going to graph the reciprocal of y equals x squared plus 2x minus 3. We can factor this. X plus 3, x minus 1. This means our vertical asymptotes are x equals negative 3 and x equals 1. So from here, we can plot our vertical asymptotes. Our axis of symmetry is the average of these two. So negative 3 plus 1 over 2. It's negative 2 over 2, so we have negative 1. X equals negative 1. And finally, our vertex is on the axis of symmetry. So we just plug in negative 1 for x. We just plug negative 1 into here. We get negative 1 plus 3 is 2. Plug negative 1 into here. -2. So we end up with -1, -4. That's the way we can plot the quadratic if it's not given. Then plot invariant points. And use asymptotes. Okay. So our invariant point is here, 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 here. Our vertex here is a minimum point, so it's going to be a maximum point for our reciprocal. And because this is -4, we have -1/4, so that's there. We are approaching this asymptote from the positive side, so this is going to go to positive infinity. And we're going to approach the asymptote from above. And by symmetry, we can do the same thing on this side. We connect the key points. And this is going to the 0 from the negative side, so this is going to -infinity. And we're done. And you can see from this example, it's not always easy to find invariant points algebraically, because these are not on grid points. So we graph the quadratic as accurately as possible, then find out where y equals ±1. Okay, let's graph the reciprocal of y equals -2x minus 1 all squared. This is in standard form, so our vertex is 1, 0. This is our vertex. And because we have the vertex, we have our axis of symmetry. It's also our vertical asymptote because it's 0. And we plot invariant points. So our invariant points are -1. We don't have +1. Then use asymptotes. Okay, this is approaching the 0 from the negative side, so it's going to -infinity. This is going to -infinity, so we're approaching the horizontal asymptote from below. And we have symmetry here. And that completes that one. So it's not difficult to reverse the process. So if we're given the graph of a reciprocal function, we can use the key points in reverse to graph the quadratic function. And that's what we're going to look at next. Okay, first step is use the vertical asymptote as zeros for the quadratic function. So here's the vertical asymptote, here's another vertical asymptote. These are the zeros for our quadratic function. Use the average of the vertical asymptotes for the axis of symmetry. 3 minus 2 is 1, divided by 2 is 1/2. Next, we use the invariant points, y equals ±1. So we have 1, 1, -1, -1. And we use the axis of symmetry to get the vertex value. So here is our minimum point or axis of symmetry. We have -1/2, the reciprocal is that is -2. So there's our vertex, our minimum point. And now we just connect all our points. And we have our quadratic function. And -1/2, and our reciprocal is -2. So that process wasn't too difficult, and that completes our lesson.